My name is Dinesh Vijayakumar, and this is my individual presentation for the MMS system design project. In this presentation, I will explain the system requirement, the use case diagram, the class diagram, the design choice we made, and how we used object oriented principles such as polymorphism, design patterns, and exception handling. Our project is to design a new system for Myriad Medical Service, also known as MMS. The current system they used is old and depends on Airtable. So MMS wants a new system that can handle patient treatment, clinician, uh, payments, and notifications. My team members are Rabia, Isa, Alok Sugmani, and myself. My contribution includes helping shape the use case diagram, finalizing the class diagram, uh, deciding where polymorphism should be used, suggesting the singleton patterns for storage, and designing the exception handling strategy and functional requirements. Members have several functional requirements. The system needs to support three type of users: administrators, clinician, and patients. Patient can register or upgrade from walk into the registered. A registered patient can log in and book appointment. Administrator can assign patient to clinician and generate bills. Clinician can update treatment detail and mark treatment assessed. Um, the system must also store treatment procedures and allow staff to flag non-playing patients. The requirement guided our use case and class structure. In the non-functional requirement, the system must follow object-oriented design principles, use polymorphism, and include CLI menu. It must also support exception handling and persistence storage, which we choose to implement through CSV file. Finally, the system must be easy to maintain and test. So unit test will be included in the final developing stage. Use case diagram. This is our use case diagram for the MMS system. We included the main actors, patient, clinician, administrators, and general staff actors. The staff actors help us avoid repeating use case because both clinician and administrators share uh, uh, some tasks. This following the DRY principle. We also added a relationship like include login, which means a user must log in before booking an appointment. We used extend cancel treatment for the case when a patient misses an appointment. Use case explain. Patient can book or cancel appointment, receive notification, and choose to OPT out. Administrators can register patient, assign clinician, update categories, and send notification. Clinician complete treatments, write consultations notes, and update treatment status. Modeling this action early help us create a clear class design later. Here is our class diagram. To keep the design organized, we created an abstract user class which store common data like name, phone number, address, email, and password. Their subclass inherit from user, patient, clinician, administrator. This shows subtype of polymorphism because each role behave differently. We also created class for treatment procedure, notification, MMS system storage, treatment status. Mm, Class diagram breakdown. The treatment class connect the patient and clinician, and it store the date, time, and status. A treatment can contain multiple procedures, so we can use a aggregation relationship, one to many. The MMS system storage class handle reading and writing CSV file. This keep file operations separate from the main logic, which follow the separation of concerns principles. The treatment status enum ensure that treatment can only be new assessed or another valid state. This uh, protects to system from invalid values. Use of polymorphism. We use two type of polymorphism. The first is subtype polymorphism through inheritance. Since patient, clinician, and administration all extend user, they can override methods like login or notification handling. The second is parametric polymorphism, also known as generic using class like array list patients or array list treatments. This gives a strong type safety and reduces error. The design patterns, we use this singleton patterns for the MMS system storage. Only one storage instance is allowed in the whole system. This prevents two parts of the program from writing to the CSV file at the same time, avoiding corruptions and improving stability. Exception handling. We design a two-level exception approach. The first level handling the technical problem like missing CSV files or input errors. We catch exception such as IO exception and file not found exception. This second level handle business logic problem like patient trying to book a treatment while they have a unpaid balance. For this, we created custom exceptions such as payment pending exception or individual invalid allocations exception. Um, the challenge and reflections. The project helped me as a strengthen my understand of the object oriented design. I learned how design diagrams translate into code, how to handle edge case, and how to design a system that is both flexible and maintainable. It also moved my teamwork and communication skill, especially when agreeing on shared design decisions. Finally, the conclusion. In the conclusion, our MMS system design following strong object-oriented principle and meets all the functional and non-functional requirement. We used inheritance polymorphism to cycle and patterns and solid exception handling to make the design reliable and easy to maintain. This design prepare us well for the final coding and implementation stage. Thank you.